So this is a session immediately after lunch. So I hope to be able to keep you awake. So my name is Wei Tai. I have been working with NSO and ConfD since 2010. And I recently started working with the Crosswork Essentials Suite product. And for the past few years, I have also been supporting network equipment providers with validating their NetConf and Yang implementations through our NIAT program. And as an extension of that program, we are now expanding into gNMI Telemetry Interoperability Testing. So here's the high-level agenda for my presentation. I'll first cover some information on gNMI streaming telemetry and why I believe interop testing on gNMI telemetry is needed. I'll introduce to you a gNMI telemetry interop test tool that we have been working on as an open source project, followed by a demo. I'll then talk about what's next and end with Q&A. So let me first give you some background information on gNMI streaming telemetry. So back in the days of SNMP, the only way to gather statistics data or state data from the devices, you rely on polling. And with streaming telemetry, now everything is being pushed from the devices into the data collectors. And now you have the capability to be streaming a whole lot of data, right, that can be gathered by the data collectors. And these telemetry data are to be consumed by machines, right? Machines that can handle big data analytics, that can be used to look for patterns or trends, right, in the network data. And that is how this enables closed-loop automation for intent-based networking. It also provides network visibility to ensure that the network is behaving as intended and running trouble-free. So gNMI is a gRPC-based protocol for network management. It has RPC calls for performing get, set capabilities, and subscribe method calls. It can be used for both configuration and network monitoring. And since the gNMI spec itself sort of make support of a Yang model or any sort of modeling language optional, I just wanted to point out this reference of RFC 9232, which specifies a network telemetry framework that in it says that telemetry data should be model-based. So when we talk about gNMI telemetry, I like to talk about model-based gNMI telemetry. So when gNMI is used together with the Yang schemas, it becomes a very good use case for streaming telemetry. As a matter of fact, the model-based telemetry has been really gaining a lot of steam in terms of industry adoption, right? If you compare that with Yang push, I've certainly noticed a lot more adoption of gNMI telemetry. As for configuration, gNMI lacks features that are found in NetConf, such as network-wide transactions. I believe that configuration is best left to be handled by NetConf. So why, okay, I was looking at the following slide. So vendor-neutral model-driven telemetry. So it's very important that data that are being gathered should be able to be easily consumed by network management systems, right? So we want to make sure that the first set of models that should be supported by a gNMI telemetry client should be vendor neutral. So back in the days of SNMP, MIP2 has been standardized. It's just about supported by every single SNMP device out there in order to allow statistics data, right, that pertains to managing a TCP/IP network to be gathered. And now with OpenConfig, it's trying to do something very similar to what MIP2 is doing in terms of network monitoring and more, right? So gNMI along with OpenConfig will really make it a very good replacement of SNMP and MIP2 when it comes to network monitoring. So how many of you are already working with gNMI telemetry or telemetry through gNMI? Okay, good. How about using gNMI for configuration? Anybody? Okay, that's good. We actually like to see gNMI being used for telemetry, but not so much for configuration. So why is interop testing needed for gNMI telemetry? The gNMI specifications were defined as an open source project by the OpenConfig working group, and Google is the main contributor. There are also other collaborators, including network operators, equipment vendors, and software companies, and the main ones being AT&T, Comcast, and Microsoft. And I have found that there are certain requirements that have been specified weren't quite well defined and were left for the implementers to interpret or decide at the implementation time. A simple example is the format of the encoding types of like ASCII and byte. They themselves are actually not defined in the spec. So now imagine a client connecting to a server and not knowing the content that they should be expecting. That's kind of interesting. And then the support of the Yang data modeling language itself is also not specified. It's sort of like, okay, it's nice to be model-based, but they don't make it a requirement. There's also the origin field, which is defined as a field which may be used to disambiguate the path if necessary. So it turns out that very few vendors would bother to make use of the origin field at all. So I would think that it is best to make it really a requirement as opposed to making it optional. So why leave room to cause differences in implementation, right? So now let's briefly talk about NIAT. So we have been supporting a program called NIAT, or NetConf and Yang automation testing, for performing interoperability testing of configuration management. It is compliance testing of NetConf and Yang standards against the service automation criteria, which actually originated from Yan, and which we have documented in our user guide for running NIAT, which explains why those criteria are important. If you're interested to learn more about it, you can read it in the NIAT user guide, which I have a link down there, which will get you to the user guide documentation for it. So the intent is to establish a clear interpretation of the standards and avoid any custom development when developing automation software for configuring different network devices, right? That are coming from different vendors. In fact, this is the NIAT program that Thomas Kabiner from Orange talked about in his talk yesterday, when he has successfully used our NIAT tools, the DrNet examiner, to test their sonic-based solution. So NetConf and Yang are both IETF standards that have gone through extensive reviews before being standardized. But even then, there are still things in them that are open for interpretation. So this is why I believe that interop testing is really a must for gNMI telemetry to ensure that telemetry data can be easily collected by gNMI clients without need for any custom coding, right? In order to deal with unnecessary variations amongst different implementations. This will help to normalize gNMI telemetry server implementations. And maybe at some point we'll have a project to try to come up with a reference implementation for this, just to cover sort of the gaps in the spec, but we'll see. And the interop testing is done to characterize the gNMI server's implementation. And the goal is to make it simple and painless for network automation and monitoring. So let's talk about the gNMI Telemetry Interop Test tool that our team has been working on. So we have been working on this open sourced gNMI Telemetry Interoperability Test tool called gNMI Test. It is still work in progress. I would say we still in beta version. There are still things that we need to finishing up before we think that it is in prime time use. It comes with a pre-built set of gNMI telemetry test cases that are automated using the robot framework. The robot framework is Python-based. There are already several talks on the use of robot framework by CX to do NSO testing during this conference. I believe yesterday there were like several sessions. So additional cases can be added by using natural language-based keywords. And the test tool performs compliance testing of gNMI capabilities, set and subscribe method calls. The test cases on the OpenConfig interfaces model are built in, and this is our starting point. We'll continue to add additional models in the near future. So in those cases, when your gNMI server that you're testing with doesn't yet support OpenConfig, or if you're also interested in testing the vendor-specific models, our tool gives you the ability to specify those as well. So you can also test vendor-specific YANG models. So the automated testing run by the robot framework generates a test report and also associated log files, which you can then drill down and analyze the root causes of the failure. So we have done some initial testing against several Cisco and third-party devices, and I'll be showing you some of my early observations of the variations that I've noticed amongst them. So here's a architectural diagram of our test tool. So the robot framework, the blue box there, is made up of 3 components. It comes with the robot framework runtime, which runs the test cases that are defined by the test data sitting on the top box, made up of the robot, the resource, and the variable files. The robot files contain definitions of the test cases using keywords. And the test cases invoke the test libraries that are written in Python, which then interacts with our gNMI client tool called gNMI-tools, which is built on top of gRPC IO tools library. And during the test run, the automated test will issue gRPC request to the gNMI telemetry test server, and it will then analyze and inspect the gRPC responses for validating the test cases. So in addition to this gNMI telemetry interop test tool, actually maybe it should have been the other way around. We actually started out working on what we've been calling the gNMI adapter for ConfD. What it is that it was a POC that can be used for both ConfD and NSO in order to enable support of gNMI on its northbound. So for those of you that may not be familiar with ConfD, ConfD is really what powers NetSIM that you use when you use NSO. It is an embedded network management agent framework. And this same gNMI adapter can also be used for NSO. We are actually in the midst of reviewing a pull request that will make it possible that it can also be used by NSO. And the reason being that ConfD and NSO, they both share this MAPI interface, which is a programmatic interface for both ConfD and NSO that allows you to access the internals of both, and which then allows you to add additional northbound interfaces that doesn't come built in into ConfD and NSO. I'm sure you're very familiar with those that are already built in, including netconf, restconf, web API, SNMP, and CLI. As this is only a POC, it certainly comes with limitations. So we have those listed in the user documentation when you go and look at it on GitHub. And for the development of our test tool, this gNMI adapter project has really come in handy. So that allows us to do a lot of the testing before we actually have our hands on some real devices to test it with. Okay, so we've tested with a few network devices with gNMI telemetry support. And as I mentioned earlier, we have observed behavior variations amongst them. So I'll discuss some of them here. The gNMI spec calls for support of OpenConfig models. However, only some of the implementations that I have tested with support OpenConfig. They all support proprietary models. And not all gNMI servers support the root path for the GET request. In some cases, when you try to gather things under the root path with the slash, what you get back is unimplemented. And there are also differences in interpretation of the origin, prefix, and path fields when it comes to specifying the path. And in particular, there's no standard way of disambiguating identical paths between models that are being supported by the server. So using Yang module names in either the prefix or the path field would seem reasonable to achieve that. However, very few servers support it. And the gNMI spec calls for JSON encoding to always be supported, meaning mandatory, but not all servers support JSON. And it seems like JSON IETF is the one that is more popular amongst the implementations. And some paths can only be specified with the subscribe calls, but not with the GET calls. I guess in those cases, the implementers decided that supporting the subscribe method calls is more important than GET. But that really shouldn't be the case. And then the capabilities response that you get back contain encodings that sometimes aren't really supported by the server. Let's say it tells us that it supported like 4 kinds of encodings. When we try to use those encodings, we get errors with some of them. And the spec has specified a few cases where the server must send a sync response under certain conditions. However, I often notice the sync response being missing. And within the initial set of updates after you place a subscribe call in the subscribe response, such as the on-change stream subscriptions, I've seen multiple updates of the same leaf elements within this initial set of updates, right? Which is incorrect. And then when it comes to support of aggregate, the update messages are supposed to be independent of each other and for resource efficiency reasons on the server, right? However, some update messages are still being aggregated by the gNMI servers, which is against the spec. And the operational data type isn't usually supported. I actually haven't seen one that supported it yet. And operational data here is not like what it means in netconf. It really refers to data that is related to software processes operating on the device. So these are just a few of the variations that I've noticed. And as we get closer to completing all of the test cases that we plan on doing, I expect to find even more. Okay, now it's time to do demo. So, oh, maybe before I do demo, there's one more thing I wanted to show first. Want to show you our GitHub location. Since the work originally started as a gNMI server, so we have chosen the ConfD developer GitHub as the location for our gNMI interop test tool. So the two projects that I will be demoing today consists of the gNMI tools, which is where the gNMI client comes from, and also the gNMI adapter and server. And then gNMI test is where the robot-based automated testing are developed in. So if you go under gNMI tools, there will be documentation that covers sort of like how you can run the server. Let's see, do I see? Okay, so this is the help page for the server command. And we are about to make the change to the -t argument. We've been calling it the API mode when we try to run the adapter with the running ConfD instance. But now that we're adding support to NSO, we're going to be changing that. We're removing API and replace it with ConfD and NSO. And then we also have a client. This is the help page for the client. Just to give you a flavor of what it looks like. And then now if we go to the gNMI test. So here, the robot test cases, they go under these two directories, OpenConfig and gNMI interface. Under each one of these folders, we have 4 suites of test cases that test the capabilities, the GET calls, and the set calls that we haven't yet gotten to because the focus has been on gNMI telemetry testing. And then lastly, the subscribe calls. So under gNMI interfaces, or in gNMI interface, the intent is to test it that are sort of independent from OpenConfig. And under OpenConfig, these will be test cases that are specific to OpenConfig. Okay, so let me now get to it. So under gNMI tools, this is where, well, let me start my previous run. So I will first build the ConfD server. So this has already a bunch of YAML models compiled in. There's some test data that we can use. And then I will run the gNMI adapter. We call that the ConfD gNMI server. And then we run it in the API mode. Again, the API mode will soon disappear. And then I'm running it with insecure. We can also run it with certificates. Okay, so now I have, what's that? Oh. Oh, interesting. What happened? Yes, let's try that again. I shouldn't have network issues to deal with. Okay, oh, I don't know what happened. Oh, okay, I had a typo. Okay, good. Thanks. Okay, so now I'm going to be running this ConfD gNMI server, the gNMI adapter, which is being run as a ConfD application, right? So we are adding gNMI support on top of the ConfD instance that I already have running. And in order to get the subscribe cases to pass, for those that expect the telemetry data to change, I have to run some scripts in order to make the data change. So these will be the ones that are non-OpenConfig specific, and I'll also run the ones that are OpenConfig specific. And let me see, okay? So maybe let me clear out of this first. That way it doesn't make it so confusing. So right now I have a bit of a long command line here, but I imagine we are going to be perhaps trying to consolidate some of the YAML files. So we may end up having fewer. But the other cases is just that I'm specifying where the output file goes. So let me maybe tell you what I meant here. So the output of the test logs and the reports goes under adapter report. Oh no, I'm sorry, not adapter results. Where is adapter results? Right here. Minus D specifies that directory. And then minus R specifies the name of the report. It goes into an HTML file. And then adapter log specifies the name of the log file. And then the other YAML files are the ones that the test cases, the robot files, will go and interpret. And if you try to make use of this tool, the one that you would be modifying would be the adapter, the YAML file. So let me show you what that looks like. So it specifies the IP address, the port number, and then also the username and password information. And then also specifies the get paths, which meaning the non-OpenConfig specific paths that the device supports. Okay, so let's see, do I have enough time to run it before that thing times out? Let me go and run it. So I can start to talk about. So under each of the robot test cases, it will give you the pass-fail result. And then maybe when it gets done, okay, it's almost done. Oh, maybe I'll have that one fail. Oh, I'm sorry. I missed it by maybe a few seconds. Let me try one more time. What happened was my scripts ran out of time, and it's not changing data anymore. So it caused some of the test cases to fail. So I want to rerun it to make sure I review the right results with you. So there are two ways to look at the test results. You either look at it from the console, which doesn't really give you the details, but you can also look at the HTML report, which allows you to look inside of the log files. Okay, now let's open up the report file. So as you see here, there are a total of 36 test cases, and 31 of them passed, and 5 of them failed. This is running against our adapter, right? Meaning this is not a real gNMI telemetry server. And for the most part, the fail cases are either that some error conditions that our adapter aren't handling properly, and in some cases we just aren't feeding the necessary data back to the test client. We can go through this. I can actually review some details with you. So in this case, this is just lacking instrumentation support on our gNMI adapter side. That there are certain leaf values that it expects to get, but it's missing. So these log files would show you that those things are not there. That's one case. And then this one, this is to retrieve the the state data. Well, the other one was config. This one was state. Again, we lacking instrumentation. So at some point, we'll make sure that we get this complete. At least the basic test cases that we have, we'll try to get the adapter as complete as we can. And then this one is sort of interesting. Because we actually started testing the capabilities response on some real server implementation that they don't use the URL format for the names of the Yang models. So we happen to have coded it looking for the ones without the URL format. But in this case, the adapter uses the URL format. So we need to make it a little bit more intelligent. So here you do see support of OpenConfig interfaces, but it's really in the form of a URL. So that's why the test cases wasn't intelligent enough to know that this model is indeed being supported. So that is something that we still have yet to clean up. And then this one. So when it looks for non-existing key value, it just expects an error response. But then in the case of our adapter, we just sort of responded silently with no content inside, so but not indicating an error. According to the spec, it really should come back with an error. Okay. And then lastly, type is the same kind of thing that gNMI spec supports like 4 different types. Now when you try to pass in with a invalid data type, it's supposed to return an error, but our adapter didn't quite handle that right. So those are the kind of things that we are looking for. Then maybe I can briefly go over the ones that passes, right? That way you have a sense of what is being tested. So we have things that look for the data types being supported. You have the config, the state, and operational, right? You have sort of those 4 types of data that you can perform a gNMI GET request on. So we make sure that each one of those data types are being supported. In some cases, when we ask for state data for a sgNMI server, what we got back has config data in it. So certainly that's a violation of the spec, right? So we look for the different data types, whether things are being processed properly. And the namespaces, whether the server supports namespaces. We notice a lot of them don't support namespaces. So you have to specify absolute paths. You can't prepend it with like the namespace of the Yang module. Then the rest are a bunch of the subscribe calls. So we do different kinds of gNMI subscriptions, making sure the server respond properly. I mentioned some of the earlier ones, right? The update messages, like missing sync response in those cases. When we run against real gNMI servers, you will see some of those failures. This would be a simple one, right? It support that the server in the capabilities responds that there are at least some servers, some Yang models in it. Otherwise, it would fail that test case. And then this is the one that I mentioned earlier, that the mandatory JSON encoding should be supported. So in our case, we do support that. Let's see. And then in the case of like on change, this is where it expects the telemetry data to be periodically changing during our test. Otherwise, it would fail the test case. So that the on change, and then there's also the polling. The polling would be simple, right? You don't expect data to change. You just poll it once, at least during with our test. And then we also send like 2 subscriptions in the single request, and try to make and test that the server respond properly. So this is on the using our adapter. So one more results that I can show you that I don't want to be running it live because of concern of network sort of issues. So I ran this test against a virtual XR device that we have in our lab. It's not the latest version, so it's a little bit older. And also, it doesn't have telemetry data that changes, right? I have nothing powered, none of the interfaces are actually carrying traffic, so I don't have live data. So I'm really gathering static data. So in this case, I also run this same 36 test cases, and then 28 of them have passed, right? So I can maybe at least briefly go over one of them for you. So in this cases, this is the case where JSON is listed as a mandatory encoding to be supported by the server. But in this version of the XR release, it does not advertise that. That's why we noted it as a failure. But again, since this is a little bit older version, I don't want to drill down into all the other failures because some of them may have been fixed already. And then lastly, to just give you a sense of how the client works, our client test tool work. Let me see, is it this? Oops, maybe the top one. Okay. So this is just so you have an idea how the client tool works, which our robot-based testing is relying on. So when I issue the capabilities RPC call, you just get back a bunch of the models that are being supported. Okay, I guess I don't have too much time. Let me wrap it up by talking about what's next. Okay, so what's next? We still have some work to do to clean it up. And then we will be adding support of more OpenConfig paths, such as platform and IF-IP. And then we would really like to be testing against some gNMI servers that have telemetry data that's changing. And lastly, please go and try out our tool. Let us know what you think, whether this is something that you believe would be useful. Give us some feedback or maybe additional things that we should be looking for. So we welcome discussions, bug reports, and pull requests. And lastly, this is the resources page. I know I am running, okay, 2 more minutes, right? Yep. So this is our resources page. I actually am running out of time for questions, but 2 minutes. Any questions out here? So feel free to go to our GitHub site and give us some feedback. Try it out. Okay. Thank you.